Hello everyone, welcome back to the channel. This is going to be lesson 5 in our unit on polynomials. Now this one we're going to talk about factoring again, factoring trinomials specifically, but especially those trinomials where you're going to see where that leading coefficient in front of our squared term no longer 1, so it could be something else. So last time we looked at what we did, we looked at what happened when that coefficient was 1, and we saw that we had a little shortcut that helped us get to the end. Now, we also looked at that longer method, which we call decomposition. So we had 2 methods to deal with those ones. Now we're going to see in this video that when we have that coefficient that's not 1, decomposition really is going to be our best method to see everything here. So we're going to start this again by looking very similarly at another table that looks very similar to the ones we did last time. And again, I'll only do one of the rows here so we can see how the pieces work again if you're just joining us for the first time. And again, in the description box, you'll see the fold out answers, solutions, all that kind of stuff. So you can try some out on your own as well. So we've got a sketch of a rectangle here. Now remember that factoring really is based on that idea that you're taking some terms or some tiles and trying to represent them as a rectangle, which would then be the area of that rectangle. Okay, now the length and the width, the dimensions of that rectangle are going to make up our factors. So if I take a look at this rectangle, I can see that there are 2 positive x squareds. So if I start writing out my polynomial, I'm going to have 2x squareds, 1, 2, 3, 4, 5 x's that are in there, and 2 1's on the end. Now we're going to notice something this time where I have multiple x squareds. Before, we only had 1. Now I have to think a little bit differently how we're going to possibly arrange some of these. So it might be a little bit more work to figure out how many groups of x's we're going to have, or what the size of those groups of x's are going to be. Now for your grid, very similar to last time, we'll think about the outside. So along the top here, I see an x and I see a plus 2. So I'm going to have an x and a 2 along the top. This time 2 x's down the side, 2 x's and a 1. So if you imagine what the expressions would say on the inside of that grid when you do that multiplication, 2x and x come together to give us our 2x squareds. We should have 4 x's to the right of them, a 1x underneath, and 2 1's down in the bottom corner. So really that grid represents what our sketch is going to be. Now our factors come from the dimensions of that rectangle. So our 2 factors are going to be an x plus 2 and the other one a 2x plus 1. So now you can see one of your factors could potentially have a number in front of the x. Before they were just x plus or minus a number and then x plus or minus a number. Here you may have a number actually in front of them. So that's what this chart is going to look like as you complete it. So again, I'll give you the fold out answer key in the description box and you can try them on your own. We are going to look at that algebraic method. So if I just read the top, remember, we are looking for 2 numbers that multiply, is what I should say, that multiply to a times c, but always add up to b. Check if we can take out a GCF first, because that's always going to be your best option first. See if you can make the coefficients a bit smaller and easier to work with. If you can take out a GCF, usually it's easier to find the 2 numbers that multiply to a times c, but also add to b. So if we look at a here, between those coefficients of 3, -10, and 8, they don't actually have a common factor. Now the one you're always going to want to try, the coefficient of your x squared. Since that 3 isn't actually a factor of either of those numbers, okay, it has to work in all 3, we can't actually take that greatest common factor out. So here we're stuck. So now what we're going to do is take that a coefficient that's not 1, take our constant, and this is what we're going to multiply together. Now before, in our last lesson, really we were doing the same thing, except our a value was always 1, which meant we were just multiplying to get the constant. But here, there actually is a number we have to think about. So we're going to multiply to get whatever a times c is, so that's positive 24. But again, we're going to try to add to that number in the middle, -10. Now last video we talked about doing this, and the reason why we did this with the algebra tiles. So here, really I'm going to have 24 1's that I got to think about placing in. Okay, that's technically what's happening. Okay. Now I got to think about what possible way I could arrange these 10 negative x's to make this possible. How can I actually create for myself a grid that would make this work? Now, if we think about some factors that multiply to 24, you could have 1 and 24. You can have 2 and 12, 3 and 8, 4 and 6. Really, those are the factors of 24. Now, we really have to look for the ones that will add to 10. So the only option that seems viable is the 4 and 6. However, we need to make sure the signs work out. Right now, they multiply to positive 24, which is exactly what we need. However, they don't add to negative 10. So here, we should actually be using both of them with negative signs. Those are our numbers. Now, before we had the shortcut, we could jump directly to our factors. However, since there's a 3 here, I can't actually do that. I have 3x squareds to think about, not only 1. So here, we really need to make sure that we use that decomposition method. So our 3x squareds are still present in our grid. Our negative 10x's get split into 2 groups of x's, one being negative 4x's, the other negative 6x's. Remember, from up above, okay, our x's are always going to be split into 2 regions, okay, 2 different parts. Our squares will always be together. Our 1's always together. The squares will get split up, okay? So if we take a look here, the only thing I have to account for is my constant of plus 8. Okay, so the constant of plus 8, your x squared stayed the same, your x's get split into 2 groups. But now it's the exact same as the method we learned last time. So we'll take 2 things, put them in a set of brackets. So 3x squared minus 4x. Now, some people like to actually leave that minus sign here and then change everything in the brackets. That's what I like to do. Or the other option you have, put a plus sign in the middle and then keep your negative attached to the negative 6. So in your brackets, you could have a negative 6x plus 8 and a plus sign in between. Really, adding a negative is the same thing as subtracting a positive. So by me putting this subtraction here and actually blocking it off of that 6, I have to make sure that I change the sign of the things I put in the brackets. Because remember that you're going to really sign inside, so you're going to have a negative 6x, positive 8. Okay, so it does work out. So let's go ahead and actually do our factoring. So we'll take a common factor from the first set of brackets. We'll take out an x. So we're going to have a 3x minus 4 inside, minus common factor between 6 and our 8 there is going to be a 2. So 2, and then again we're going to have a 3x minus 4. Now our brackets are the same, which is exactly what we need it to be at this point. So 3x minus 4, there's one factor. The other one, the other dimension of this rectangle, is our x minus 2. So there we go. There are our 2 factors. There's the dimensions of our rectangle. Okay, very, very similar to the method we looked at last time. However, you just have to remember that there is that coefficient in front of our x squared. So that just changes what we're going to multiply to. Okay, again, these are very, very similar. So we'll do C for sure because that one's got a couple variables. So we're going to talk about that one. Now, for B and for D, again, they look very similar. But sometimes you might get to a point where you actually find out that really there's no 2 numbers that satisfy those conditions. So if we actually take a look at D, we're really going to try to see if we can find 2 numbers that do this. 2 numbers that multiply to the product of 2 and 7, so positive 14, but the same 2 numbers need to add to positive 6. You know, if I think about all the things that multiply to 14, it's 1 and 14, 2 and 7, and those are all my choices. There's no possible way for either of those cases to add up to 6. So what we would say in that scenario, really this isn't factorable. Okay, it can't actually be written as a product of 2 factors. Now, this has more application in Math 20 when you get to actually talking about those quadratic functions and their graphs. But if I can't factor it, that means it doesn't cross the x-axis. So if you were to draw this graph, you would see that the graph does exist, right? It is possible to graph it. However, I believe it's somewhere up here. Okay, so that's what that graph would actually kind of look like, not actually crossing that x-axis. That's going to be a concept that we look at in Math 20-1, actually, and -2. Okay, but for us, for Math 10, if I can't find 2 numbers to satisfy those conditions, we would say it's not factorable. Okay, so let's talk about C. Now looking at it, I have two variables to worry about. I've got 5x squared minus 24xy minus a 5y squared. So I've got y's and x's in here. Now I'm going to check for a common factor first. So between all three terms, they do not share a common factor of 5, nor x, nor 5. So really that is not good for us. Now I have to figure out how the heck we're going to deal with this. Now, if there's a y and an x in your expression, you're going to treat one of those variables like it's part of the constant. Okay, now we're always going to leave, that x being our variable that we want. So we're going to take y to actually be part of the constant. Okay, so we're going to look for two things. And there's my color. 5's my a number, the number in front of my squared. Now we're going to multiply that with the whole thing here. We're going to take that y to be part of this constant. Okay, so we're going to multiply to give us a negative 25y squared. So now we're not only looking for the number that makes this possible, we're going to need a variable attached to it as well. Okay, now we're going to add to the stuff that's in the middle. Okay, we want to add to negative 24, but we also want to add to negative 24y. Negative 24y. Now think about the things that multiply to 25 first. So it could be 1 and 25, or 5 and 5. Now if I need to actually add to 24, this is obviously my only choice, some combination of 1 and 25. But remembering that I have to have the y's dealt with as well, so the things we need are actually a y and a 25y. Because if I think about this, y times y is y squared, y plus y, well, it's like terms, so they'll have the same variable, it's the coefficient that we change. I need it to be a negative 24, so this should be a negative 25y multiplied with 1y. That will satisfy both conditions. And when we actually go to do that decomposition, again, remember it's just the middle term that gets split. So my 5x squared will stay. That negative 24xy will get split up into two pieces, and I have to have that x attached just like we did above, no different. Technically these are just algebra tiles as well that not only have dimension x by 1, they have dimension now x by y. Okay, different size tiles. So this one, these two terms will go in the middle. So a minus 25xy plus an xy, and then minus my 5y squared. So that negative 24xy is just getting split into these two pieces instead. Now it's the same question as before, so we'll group our stuff together. Plus, and there's xy minus 5y squared. So there we go. Now I can look for a common factor in each group, so we'll take out a 5x from the first set of brackets. We'll be left with an x minus 5y, that's what it looks like. From the next set, we'll take out a y as well. So inside you're going to do xy divided by y, that's just x. Minus 5y squared divided by y is again a minus 5y. Our brackets are the same, which is exactly what we need. So this equals x minus 5y multiplied with 5x plus y. So there's my dimensions this time. If I were to draw this out in tiles, I'd have to have a tile that represents x and a tile that represents y. So I'd have to have different sizes to actually make that work, which makes it trickier to draw, but algebraically it works out the same. Okay. For all of the other ones in here, you can approach them the exact same way as the two that we talked about. So I'll give you the answer key for those and you can try them out. So they're all very much so the same. Look for a common factor if possible. So for h, all of those coefficients are even, so you're going to have a greatest common factor of 2 when you attempt that one. And again, you'll have all of the answers to these as well. So let's talk about this one here, just the last one. So the volume of this rectangular prism represented by this expression. And remember that volume is equal to the length multiplied with the width multiplied with the height. So if it's a rectangular prism, technically it's the area of the base. So length times width is the area of a rectangle. So that's the area of the base multiplied with the height. Okay. So we are asked to determine one possible set of dimensions for this box. I need to find some possibilities for length, width, height. So if I take this expression, and that's the volume, right? So volume equals 8x cubed plus 6x squared minus 2x. We're going to have to factor this. Now, if I look, each of the terms have a factor of x, and each of the coefficients are even. So it looks like a greatest common factor is going to be 2x. So we're going to have a 4x squared plus 3x minus 1. So inside the brackets is really what we're trying to deal with. That's really what we want to factor. So we're going to do it the same way we did before. So we're going to look for two things that multiply to something, add to something else. Now remember that there is that number in front of the x squared. So we're going to multiply to give us negative 4. Okay, our 4 multiplied with negative 1, so I need negative 4. And we want to add to positive 3. I want to add to 3. So it could be 1 and 4, or 2 and 2 are the options that multiply to 4. Only one possibility that would ever add to 3. Now I need to make sure the signs work as well, so I need to multiply to a negative, add to a positive, so this should be a negative 1. So negative 1, positive 4 is what we're actually going to need. Okay, so now we can do our decomp. This becomes a 4x squared minus x plus 4x minus 1. I can group some stuff in the brackets, so 2x, 4x squared minus x goes together, plus a 4x minus 1. If I look at that second set of brackets, that 4x minus 1, there's no common factors, so I know that's going to be one of our dimensions here, because I'm going to try to get this set of brackets, the first one, to look like the second one. Now by doing so, I can take a common factor of x out, so I get 4x minus 1, plus, again, my 4x minus 1. Okay, so it's factored. Let me give us a little bit of room. I shrink in that. And we'll zoom back in for you. There we go. So in final factored form, I am going to have 3 distinct factors here, 2x being one of them. Another one is going to be my 4x minus 1. And the last one comes from my x that was a common factor plus 1. This is what people will forget. Technically, that counts. Okay, so really this is x plus 1 for my other factor. Okay, and again, it is volume. So if you think about this, it's x times x times x. That gives me the cube, right? If I've got a volume, I should have 3 factors. 2 might be the same, but I should have 3 of them. So there it is. There's my expression for the volume, and it's factored. That's important. Okay, so now underneath, we're asked, or we're told now, that if the value of x in the expression is 2, determine the actual dimension. So before, when I factored it, I didn't actually know what x was, right? So this expression could represent any box, right? X could be anything. Now x represents an actual number. So now I'm talking about one specific box where x is equal to 2. So we need some dimensions. We've got a length, we've got a width, and we've got a height, right? So 3 things. Now, it doesn't really matter which one goes where, because multiplication can get rearranged in any order. Usually length is the longest, width is the other one, height's the height, the tallest one. But it's hard to determine that if these are all linear dimensions. So it really doesn't matter which one you call which. So let's put our 2x here. I'm just going to go in order. And x plus 1. Now, we know now that x is 2. So wherever you see x, put in a 2. So really this is 2 times 2. One of the dimensions is 4 centimeters. If it's 4 times 2 minus 1, that's 8 minus 1, that's 7 centimeters. And the last one, 2 plus 1, that is going to be our 3 centimeters. So here's the dimensions of that actual box. If we actually needed the volume of that box, that volume would be equal to 4 multiplied with 7 multiplied with 3. So that's going to be 21 multiplied with 484 centimeters cubed. Now let me just double check the math. So we have the right number, 7 times 3 times 4, yeah, 84 centimeters cubed, if we were asked for it, right? I would take my length, width, height, and multiply them all together. Okay, but that's it, factoring trinomials. Exact same process using that decomposition method to figure out what we have to split our x's into to make sure our tiles fit in the grid. Exactly the same method we looked at in our last lesson. Next time, or in the next video there, we're going to look at a couple special cases. What happens when things are binomials? Can we still factor them? Is there still a method for that? what happens if my tiles don't make a rectangle but they make a square? Is there something different I can do there? So that's what we're going to look at in the next one. So you'll probably see the links pop up here in a second. So again, I hope that these are beneficial, worthwhile, all that kind of stuff. So check back for the next one. And you can always reach out to me on Instagram, Twitter. You can send me an email as well if you do need anything. So take a look back in the description box for the answer key, and we'll see you in the next one. Everybody take care.